In this problem, it says that we have a data set of brain volumes and IQ scores for 9 males, and that the linear correlation coefficient is R equals 0.347. So we are going to use the table of critical values of R to determine if there is a linear relationship between the brain volumes and the IQ scores. So this is how we go about doing this. I'm going to make a number line, and this number line encompasses all the possible values of our linear correlation coefficient. So the linear correlation coefficient is a value that represents the strength of the relationship between two variables. So that can range anywhere from -1 to +1. And of course, that means that 0 is in the center here. Now, when we are determining the strength of a linear relationship, we have to know the number of pairs of data, because the more pairs of data we have, we can see in the table, the lower the critical value of R needs to be in order to say that there's a strong linear relationship. In this problem, we are told that n is equal to 9. The number of data pairs is equal to 9. So I'm going to look at 9 pairs of data. That means that my critical value is 0.666. So I can label my number line, and I'll put a positive 0.666 on the right-hand side, and I have a negative 0.666 on the left-hand side. So now I've broken my number line into 3 zones. And for the first zone that we have, anywhere from -1 up to negative 0.666, we would say there is a strong negative linear correlation. If we're anywhere from 0.666 to 1, then we have a strong positive linear correlation or linear relationship. And then the third possibility is that we fall in between positive and negative 0.666, and we would say that we have little or no linear relationship or correlation. So now we have to look at what is the value that we were told for this particular data set. When you get to chapter 10, you'll learn how to calculate the linear correlation coefficient. But for now, they just tell us that R equals 0.347. So that's where I'm going to locate this on my number line, 0.347. And I'm just approximating. I just need to be in the right zone. So I don't need to measure out exactly 0.347 from 0. And so this is where our value of R is, and that tells me that there is little or no linear correlation. So since the correlation coefficient is between negative 0.666 and positive 0.666, that there is not sufficient evidence to support the claim of a linear correlation. So I'm going to write that here, between negative 0.666 and 0.666. there is not sufficient evidence to support the claim of a linear correlation. And that's how that problem works.